Hi everyone, I am Sajpal Singh from BE Global course and this is the demonstration video of task 7.2b, which is to create a robotic swam. For this task, I team up with Samrit Mahajan. In this team project, I made a master car and Samrit work on a slave car. Before going further into the video, let me introduce you with the robotic swam. Robotic swam is basically a true robot or a group of robots from which one is main robot, that is the master robot, and another is the secondary robot, which is the slave robot. Slave robots are meant to follow the master robot. As I work on a master robotic car, so here is the explanation of it. In the previous task, 6.1p, we ended up making a Bluetooth car. Now to make a robotic swam, I used the RF module. It contains of two components, one is transmitter and another is receiver, which are used in the master and the slave car respectively. This is a transmitter. As you can see, it contains of 3 pin, which is the ground pin, data pin and VCC pin, and another is the this antenna pin, which transmits the signal to the receiver. Talking about the connections, we connect this VCC pin with the 5V pin of the Arduino, data pin with one of the digital pin of the Arduino, and ground pin to the ground pin of the Arduino. So I connected the data pin of this transmitter with the number 3 digital pin of the Arduino. Rest all the connections are the same as of the Bluetooth car. Now when the signal is received by this Bluetooth module, it will transmit to the Arduino. Arduino transmit the signal to the motor driver unit of this car and to the transmitter of this. The transmitter will transmit the signal using this antenna, and that signal will be cast by the receiver of the slave car. So as if now, both cars are working on the same signal and the slave car will perform same as the master car. Now let's quickly go through the code of the master car. So this is the code of the master car. Here you can see the setup function. In the setup function, the pin for the robot motor are set as the output pin, and the serial communication is initiated with the baud rate of 9600. The VW set TX pin function set the pin used for transmitter data through the RF module, and VW setup sets the virtual wire library with a specific data transfer rate of 2000 bits per second, as you can see here. Next we have the loop function. In the loop function, the code checks if there is any incoming data through the serial communication using the serial available function. If there is the data available, it is read into the variable t using the serial.read function. Next step, depending on the value of the t, the code will send a specific character to the RF module using the VWSend function. It then waits for the transmission to complete using the VWWait.tx function. Finally, the code will call a function based on the value of the t. Each function controls a robot's motor to move robot in a specific direction. As you can see here, we have forward. All this forward backward code are written here. Forward, backward, right, left and stop, and these are respectively called depending on the value of time.
Sajpal Singh has explained everything about the master car. Here I am Samrit Mahajan is going to explain about the slave car. Here I connected the receiver which will catch the signal from transmitter of the master car. This is how the receiver looks like. It has VCC pin, ground pin, get output pin, sender and interval. I have connected the purple wire to the 3.3V of the Arduino. The blue wire is connected to the third digital pin of the Arduino, and the green and white wire is connected to the ground pin. Now let's jump to the code of the transmitter. Here I have included libraries like virtual wire and virtual wire underscore config for the code. The setup function is defined, which setups the pin mode for motor controller, initializes the serial communication, configs the RF receiver pin settings and start the receiver. In the loop function, an array buff is declared to store the received message. The VW_get_message function is used to check if a message has been received. If so, it proceeds to the corresponding action based on the receive command. The receive command is compared using an if-else structure to determine the appropriate action. L stands for moving forward, which calls the forward function. G corresponds to moving backward, which calls the backward function. L stands for left, which calls the left function. Similarly, R corresponds to turning right, which calls the right function. S corresponds to stopping, which calls the stop function. The code defines separate functions for each type of movement: forward, backward, left, right, and stop, to control the modules connected to the corresponding pins. This code set up the Arduino board to receive commands wirelessly using the virtual wire library and controls the robot wire's movement based on the received commands. Thank you.